Our presenters today are both from APH, Joe Hodge, Technical Innovations Product Manager, and Jim Sullivan, Director of Social Enterprise, and they will be both presenting for us today. Some challenges, some things that may be things that you struggle with. The culture of STEM courses in your school or your district may very well not be very inclusive. Your students may lack confidence in their abilities to handle things like math and science and STEM content areas. Vocational and educational goals are hampered by lack of experience and exposure to STEM activities. So we're going to talk about how to deal with some of those things today. And finally, our learning objectives. So we're going to identify 7 core practices of the K-12 computer science framework, list 4 parts of the Codejumper lesson plan structure, describe what threading is, and identify how threads are created in Codejumper. And with that, we'll turn it over to Jim and to Joe.
Sorry about that. I needed to unmute. Nikki, can you move to the next slide? Thank you. So welcome, everyone. We're very glad that you could be with us here today for this webinar where we will do a bit of modeling for you. We'll get into some details about the lesson 4 on threads. We're going to talk about this core practices in K-12 computer science, and then we'll also get into describing and talking about Codejumper. So if you participated in a few of these webinars, there will be some stuff that you've seen before, but there will also be some new content that we'll be sharing with you, and this will be recorded. I do want to mention that these 7 core practices that we're going to talk about throughout the course of the webinar, they are in the form of a handout, and I believe Betsy Ann has just forwarded you the link to where you can pull down the handout, as well as lesson 4 in codejumper.com is a great place for some of these resources. So in doing some research for this presentation, I came across 7 core practices that are often found or should be found in a K-12 computer science framework. And the framework was really designed to provide guidelines for what should be in a curriculum for a computer science or a coding course, right? And these 7 practices that we'll talk about are paired with 4 concepts. So we want to talk first about those concepts that go along with these practices. And so one of those concepts is equity, that when you're considering curriculum, you should consider equity and really broadening the participation by all students. Another theme that is a part of these practices is the idea of powerful ideas, that as you are considering curriculum, you are in the long run considering how kids can use the ideas that they're learning to really solve real world problems. And an example of that would be, say, clean water, say in Africa. And while today we're going to be building threads and having fun, we are creating ideas that the kids can use to, or giving them concepts that they can use for bigger picture items. Another theme that will appear within the framework and the practices is the idea of computational thinking, and that is to formulate a problem into steps. That there's we're going to do this first, and then we're going to do that second, and then we're going to do that third. And then last, a theme within the framework is really a breadth of application. And so when we think about teaching computer science, we're going beyond just coding. We're getting into the idea, for instance, of something like networking, and what does it mean to network computers together, and what are the benefits and what are the consequences. So anyway, as we move throughout today, we will pause and we are going to talk about some of these practices. And again, these practices are going to be found in the form of a handout, and they should fit very nicely into some examples that you're going to see today. And so with that, let's move to the next slide. All right, so today we will be incorporating elements of lesson 4, which is threads or threading. And just to clarify from the outset, a thread is a series of commands or tasks that can be carried out at the same time as another set of commands. And so what you're going to see today is Codejumper and 2 threads in Codejumper with 2 sets of commands that are going on simultaneously. And there'll be a cacophony of sounds that will be happening. But this idea of threads and what a thread is something that we want to bring across throughout today. And that is found specifically in lesson 4 of the Codejumper curriculum, which you can find at codejumper.com. All right, next slide, please. All right, so we come to our first poll question right off the bat. I talked about 4 themes that are running through the K-12 computer science framework. So Paul, you want to jump into this poll question for everybody?
All right, so we would like you to select the 4 themes running through the K-12 computer science framework. Pick all that apply. Your choices are equity, quantum theory, powerful ideas, exclusion, computational thinking, and breadth of application. Choose all that apply.
I don't suppose that we've had any questions come in at this particular point in time with the presentation. But I will say, as you guys are reflecting on this question, you are going to see all members of the cast today being a part of some of the stuff that we'll be doing. So we're going to get a little bit goofy here in a bit. So, and hopefully, oh, you're only able to select one in the poll. Ruh-roh.
Oh no, I apologize for that. That's on my end.
So I guess with that being said, what we could do, because we have had 5 of the 6 that have been selected so far. Equity is one of those themes. Powerful ideas is one of those themes. Computational thinking is one of the ideas, and breadth of application is another idea. Exclusion is not one of the themes that is running through the computer science framework. So sorry about that, everybody. Why don't we move on to the next slide? All right, so Joe, are you there with us?
Yeah, can you hear me?
Just fine. All right,
Awesome.
so everybody, we want to talk a little bit about what Codejumper is before we get started. So with that, Joe, what is Codejumper?
So Codejumper is a physical language designed by Microsoft and developed by APH. Is to teach basic computer programming concepts to children ages 7 to 11.
All right. So Joe, can kids who are younger than 7 engage in Codejumper? Kids who are older than 11 engage in using Codejumper?
Yes. So Codejumper is really fun in that, I've gotten the chance to kind of help take this around to different summer camps and different ages of people. So, folks who are younger than 7, they like it because they can turn the dial and hear noise. They're not necessarily going to understand the sequencing more than likely of why things are working the way they are, but it's getting them in, sort of encouraged when they do something, something's going to happen, and they're going to hear the clicks, the sounds, and it's just going to be fun for them. For older kids and teenagers, I think Codejumper still has value because it's going to teach you concepts that you're going to use in programming. So it may be a situation that you've not had any programming experience or teaching. Let's say you're 13 or something and you just start taking a coding class. You can actually feel a loop, or you can feel how things are arranged. You can kind of learn about if this then that statements. So Codejumper is fun, I think, for anyone.
All right. Nikki, can you go to the next slide? All right, so Joe, how does Codejumper work?
So Codejumper is similar to block style coding, but tangible. it teaches you with physical pods and audible audio sounds, audio feedback, actually, sorry. So it's things like songs, stories, themes, sound sets. You can actually customize your own sound sets, and it allows you to put all of this into practice and have that physical component.
Okay. Are you able to bring in your own sounds?
Yes. So we have a custom sound set, so you can actually make the sound set over whatever you want. So let's say it's like pizzeria. You can create, you can have sounds of wood fire grills and pizza shakers and different sound effects to accompany that sound set.
And what file types do those sound sets need to be in?
They need to be in WAV or MP3.
So no MP4.
No MP4, correct.
All right, very good. All right, Nikki, how about the next slide? All right, so Joe, where are we going to find Codejumper being used these days?
So we're going to see it in individual instructions such as classrooms, home, especially now with COVID. It was really nice to have that physical component to teach things that may have been on a projector or a screen where kids can kind of get their hands on it. We have group instruction. So again, you can actually use it in the classroom with kids together using it. And the neat thing is when we go over the pods here in a second, it's inclusive where everything has a different shape or color. So you're able to easily tell what part is what. And it allows the blind child and the visually impaired child to, have the same footing as the sighted child. So we also see this in camps. So as I mentioned, kind of summer camps with the NFB or different organizations. And then after school coding classes. So we kind of see this everywhere. That I've kind of gotten talked to about even college courses using it for sort of, having fun after, a long day. So we recommend one kit to every 3 to 4 students.
And do all of these kiddos need to be blind and visually impaired?
No. So as I mentioned a little bit earlier, we're gonna when we get into showing the parts, everything is basically designed for inclusive learning. So everything has a color or a different feel, and sighted kids are gonna love kind of just hearing the sounds and telling a story as well.
Yeah. All right, Nikki, can we get to the next slide? All right, so we get to the first core practice that I wanted to mention, and we're not going to spend a lot of time on these, but we're going to bring these up. And so the first core practice as a part of that framework is really fostering an inclusive computer culture. And this photograph is of a young lady who is working with one of her peers on Codejumper. She's leading in rather closely to the screen to be able to view what the code looks like, and she is manipulating the one of the play pods at the same time. So we do want to emphasize that again, when you reflect on your school or your district, and the kids are working, whether it's in elementary school or in middle school, on coding courses, if they are part of your curriculum, are they doing it in such a way that everybody is included, or are they working independently, or for whatever reason due to access or equity that there are certain kids that aren't able to do that? And if that is the case, this framework would be great to bring forward, because that core practice of fostering an inclusive culture really should be thought of from the get-go. All right. And you're going to see that in some of the photos throughout today, as well in some of what we're doing. So if we can move on to the next slide. All right, so we get back to another poll questions right off the bat. So Paul, you want to go ahead and read this question?
Okay. Codejumper introduces which of the following types of coding? Codejumper introduces which of the following types of coding? Block coding, text-based coding, Java, or C++? Should be able to pick one. Which of the following types of coding does Codejumper introduce? Block, text-based, Java, or C++?
All right, so we've got some responses that are rolling in. I think we had a question about whether or not this can be acquired in India. And one of the things that we can do is put you in touch with Humanware. Humanware is our international distributor for Codejumper at this particular point in time. And it is a conversation that Humanware can assist with. And so, I don't know, Betsy Ann, probably the thing to do would be to shoot. Did you just send a link to the Humanware piece? Perfect.
I did. This is the Humanware International division where you can find Codejumper to purchase on Humanware. They've got an email address and a phone number up at the top of the website. But if we need a contact person, who would you recommend?
Yeah, okay. You know, this could be that point in time, Betsy Ann, where we make that statement. I've worked with teenagers. I can wait to get more participation from the audience. We only have 43% of the audience that's weighing in. So does that mean people are nodding off or multitasking?
Oh.
The answer to the question, Joe, is what? What kind of coding does Codejumper introduce the audience to?
Block coding.
All right, very good. And where else are you going to find tools that teach block coding?
Where? What do you mean?
What other software, what other tools would we find that teach
So
block coding?
There's like Blockly, there's different things, but the biggest issue and the reason that kind of what Codejumper is addressing is a lot of the website or a lot of the different applications out there like Blockly and things are inaccessible for blind and visually impaired folks. It's coming along, but it's still fairly difficult to use with a screen reader at this point.
Yeah, very good. All right, I think we're going to talk a little bit about lessons now. Nikki, if you can advance the slide. Oh, actually, I'm wrong.
Nope.
We're going to look at the Codejumper kit. All right, so I'm going to go ahead and do a share screen.
We're looking at the app first, correct? Actually.
Oh, that's right. Thanks, Joe. Nikki, can you bring that back up for a second? Sorry about that. All right, so everyone, we're going to take a look at the app, the hubs, the pod, and the plugs, and then we'll get into some resources. So next slide, Nikki. All right. So Joe, here we've got the Codejumper app up on the screen. So can you describe the app to everyone and let everyone know what platforms the app will work on?
Yep. So this is what you're looking at now is the Windows app. We also are on Android and Chromebooks. The app does look a little different on Android and Chromebooks due to just screen sizes and how Android kind of works. You have sort of multiple screens. You don't see everything on one screen, but ultimately everything works the same. So how this is laid out here on the Windows side of things, what you're looking at, we have a Bluetooth indicator at the top. So we have kind of some icons at the top. We have a Bluetooth icon indicator, which tells you if you're connected or not. We have a musical gear, which allows you to, if you choose that, you can add custom sounds. There's a lowercase I for about. There's a right arrow for playing the program. There's a megaphone for reading the code out loud. And then there's a square for stopping the program. And all of these are read by a screen reader. You can use this with on Windows, JAWS, NVDA, and even Narrator. And then on the Android side, you would use TalkBack, and on the Chromebook side, you would use Chromevox. So below the buttons there at the top, you have 4 different threads. So these are kind of what this session's about, kind of how threads work together. But you're going to see 4 thread codes that you can choose different sound sets for. And now we can go to we can actually stop and go to the actual Codejumper kit here and kind of get into that.
Got it. All right. So I'm going to go ahead and do a share screen. And I'm going to make sure that I share my sound when I do a share screen. And I'm going to maximize this window. And, oh, for some reason, we are not getting what we had previously, are we, gang?
No,
All right. Sorry, guys. Let me move this a little bit
that's helpful.
closer.
Yeah.
Yeah, for some reason, as I bring these pods in, it is having an impact on what you guys can see. Is the I want to start with the hub. Is that any
hub.
better? Is that any better, guys?
Yeah,
That's it.
it's better.
Okay.
We've got a little bit more definition.
Okay. All right, Joe. You want to go ahead and describe the hub to everybody?
Yep. So the hub is the brains of the operation, so to speak. So what you see is it's a sort of a device that has two buttons. They're play and stop. There's a volume dial. So the play is kind of real quick, is a triangle shaped button. The stop is a square. Kind of just like the app, actually. The volume slider is like a traditional kind of old time radio. A lot of your radios kind of had it. It feels like it's really cool. It's very satisfying. And it has 4 ports along the side, the front, well, kind of the front edge, and those are your threads. So those will go 1, 2, 3, 4. These allow for the command pods to be plugged into it. So they're just a 3.5 jack that these pods that we'll explain here in a second plug into.
Okay. What kind of batteries does it take, Joe? Is it AAA or AA?
These take 4 AA.
4 AA. All right. So you just flip it over on the back and then pop it out. Great. Okay. All right. What are we going to meet next? Play pod?
So we got, yeah. So in the box, you're going to have play pods. You're going to have 8 of these. So on the play pod, you have a wire that's got the 3.5 jack that will plug into the hub. Then on the top, you have 2 blue dials. And the reason I'm kind of mentioning the colors when I can is because, again, everything is a little bit, you can kind of feel the difference between these pieces and you can see the difference between the pieces. So on the top, you have what's called the sound dial. It's a flatter sort of donut shaped dial. This changes the sounds in the sound set. And then we have a duration dial, which is a taller dial. And that's going to change the frequency or speed. Moving on, we have a pause pod. We have 3 of these in the kit. This is an orange, one orange shape or color, and it's got an orange dial, and it's got just 1 dial on this. And this will delay the sounds between your code. So basically you can stop something for, let's say, 1/2 beat. You can just kind of create a pause. And so if you're telling a story, that's kind of important to maybe pause something for the effect. The range is 1/4 to 2 beats, just to kind of give you an idea there. Next, we have a loop pod. You get 2 of these in the kit. They have 2 wires on them. It's probably my favorite pod. So it does kind of what the name suggests. It can create a loop. So basically you can kind of have a sound or something repeat. And there's 1 dial on there that's yellow, and that changes the number of how many times it's going to repeat or loop in this instance. So with this, you have the 2 wires, 2.3, 3.5, and it also has 2 jacks on it that you can plug into a play pod and continue on your thread. We have a selection pod. These are 2, they're green. So this is your sort of if then this pod. So you have 2 dials and 2 3.5 jacks. So this is where you can set a number, and if it's greater, it'll play 1 sound. If it's less than, it'll play another sound. So it's pretty cool. We have a merge pod, which is green. So this is sort of you would hook this up with the if then this, and you can continue on your thread, but also it basically merges everything back together. So now to the fun part, we have little plugs. So we have constant plugs, which we have 8 of, and these have raised dots on them. So you can actually feel a dot 1 to 8 on them. And you just plug these into the PlayPod dial, the donut shaped dial, to create whatever number you're wanting to set something at. We have a random plug with the raised R. So this would create a random sound in a sound set between 1 and 8, depending on how where you plug that in. We have an infinity plug. It's got the infinity sign that you can feel raised. And this is the one that a lot of kids that I work with love because it'll just keep a sound playing until you hit the pause button. We have counter plugs. We have a plus and a minus plug. They're purple with we have a raised plus and a raised dash sign on it. And then we have variable plugs. And we have 3 of those.
All right.
And finally, I don't know if you have this, Jim, because last time I don't think you did, but maybe you have it in the kit now. We have an extender cable. So if things get a little crazy and you're running something complex, you can sort of extend your code out and have create a little bit more room for yourself.
Yeah, I do have it, but it's off camera.
Okay.
Yeah, so that comprises the kit itself. So a kit is made up of all of those. It is not assigned to any particular application. It can move, from one computer to the other, or one Chromebook or one Android device to another. So it comes in a case that you can carry with you from place to place. And as we said, we recommend one kit for every 3 to 4 students that you're working with. So,
and one other quick note: the hub is Bluetooth. So when you connect it for the first time, it acts as a Bluetooth speaker with Windows as well. So just as a sort of for your information.
All right, so I'm going to go ahead and stop sharing. And Nikki, if you wouldn't mind going ahead and sharing. And then moving to the next screen or the next slide. All right, so we'll get to another core practice here. This is the second of the 7, and that is collaborating around computing. And this is a photograph of 3 younger elementary school students that are sitting at a table with Codejumper with either an aide or a teacher that would be assisting. And so that collaboration around what is going on in the classroom is something to consider when thinking about curriculum and activities for students. And certainly, as you can see, or we've talked about thus far, Codejumper is definitely something that the students will be able to collaborate on, and you're going to see some of that collaboration here in a second as we get into the unplugged activities. So Nikki, can you move on to the next slide? All right, so we're going to introduce the lesson. So I2E is an organization that works closely with Microsoft. Microsoft was really, and the Torino project was really the foundation of Codejumper. APH collaborated and brought Codejumper across the finish line in terms of the development of the product. I2E came in and created 19 lessons. There are 8 primary lessons and 11 advanced lessons that you have access to at codejumper.com. Journaling to track progress is a part of those lessons. As you work with Codejumper, it is not possible to save any of the work that the kids are doing. So you can't begin something and then continue it on, save and continue on. So you're going to track their progress through journaling. And at the end of each one of the lessons, there are 2 assessments, really, which are projects. So the projects are outlined for the students, and then there is a rubric that's available to go ahead and assess the project that the kids have worked on. And these lessons really all tie back to the national computer science technology standards at the different grade levels. And so as you are looking at this as an option for your students, it will be very easy for you to be able to tie the lessons and what the kids are learning, the vocabulary, etc., back to what their peers or doing, or what any curriculum should be doing at the particular grade level in which you're working with the kids. Nikki, can you move on to the next slide? All right, so this is one of our learning objectives today, and that is what is a lesson made up of? A lesson is made up of an unplugged activity. So that is something that's done offline, something that you don't have to use the pods and the Codejumper kit to work with. The lessons also include one or several guided activities where there are very specific examples that are given for the kids to walk through. And there are, we point to resources, videos, and what you need in that guided activity. So you'll need a hub, you'll need 2 play pods and a pause pod. And here are links to videos to tell you how to connect the hub, what the play and what the pause pod do. There is also an exploration activity where the students can get in and take concepts that they've learned and do things then on their own to build their own stories, to build their own songs, to work with their own custom sound sets. And here, what we've heard anecdotally from teachers is that kids begin to discover concepts and ideas that they will learn in the future. And then the last part of any lesson is a check for understanding. And that is kind of going back and identifying through the journals that the kids have the vocabulary and the concept and are ready to move on to the next lesson. All right, let's move on to the next slide. So 2 more core practices. The third core practice is recognizing and defining computational problems, right? That is problems that can be solved in a series of steps. And then communicating about computing. How is it that we are going to solve whatever this issue is, or how are we going to pull what it is that we need together to complete the task or the activity, that communication that goes on. And Nikki, if you move to the next slide, we'll get into the learning objectives specifically within lesson 4, and that is students will understand what a thread is. Students will understand that computer programs are created using multiple threads, and we will understand how to create multiple programs containing multiple threads. Right? Again, on how to create a program containing multiple threads. I think I threw one too many multiples in that last statement, right? Right. And so if we go back again to the idea of what a thread is a series of commands that can be happening simultaneously that really form the actual program itself. And so I believe if we move to the next slide, we're going to get into our offline activity. And this is where we get group participation from everyone. So if you guys all want to turn on your cameras, what we're going to do is we're going to model this offline activity. All right. And so I'll be the leader of the group here. And so I see everybody's turning on their camera. Welcome everybody. We got Jeff, South Florida Schwartz with us here today, coming over from the outreach side of the program. He graciously agreed to be a part of the shenanigans here. All right, so if I'm leading this, I'm going to be saying to everybody, okay, we're going to talk about this idea of threads, and we're going to use some sounds to do that. And the very first thing that we're going to do is we're going to do something with barnyard sounds, right? And so the sounds that we are going to be coming out of the barnyard are going to be, for example, what Betsy, Ann, what's an example of one sound that we're going to hear in the barnyard?
Well, my favorite barnyard animal is a cow, so I would choose moo.
All right, and Nikki, how about you? What's another barnyard animal that we're going to find?
I'm going to have to go with cat.
Cat. All right. What's the cat?
Solid meow.
A solid meow. Okay. All right. So guys, if we're going to put these sounds together, is it plausible that, what we might be recreating is like Sunday morning just before feeding time in the barnyard?
Yes, let's do it.
It's
Yeah.
plausible. Is it actually? Probably not. Okay. All right. All right. So we said, Betsy Ann, you wanted to be the cow, right?
Yes.
All right. Very good. And Nikki, we said you wanted to be the cat, right?
Yep.
All right.
I'll take the dog.
Paul's going to be the dog. Great. All right. Hey, Joe, how about if you be the duck?
Quack, quack.
All right. All right. Jeff, you want to be the pig?
Oh, absolutely. Quack, quack.
All right. All right. And I'm going to be the sheep. Very good. All right. So we've listed these out. So Sully's the sheep. All right. So the easiest thing that we could do is we could just sort of put them in the order that I just wrote them down to keep this simple. So Betsy Ann, when we start running our program, you're going to be the first sound, right?
Great.
Okay. Nikki, you're going to be the second sound. All right.
Okay.
Paul, you're going to be the third sound.
Got it.
Joseph, you're going to be the fourth sound.
All right.
All right. Jeffrey, you're going to be the fifth sound. And I am going to be the sixth sound. Okay. All right. So when I say run, which would be the equivalent of pressing the play button on the hub, we'll start making our sound. So everybody know where they're at in order?
Absolutely.
Yes.
Yep.
All right. All right. So on the count of three, we'll get to run. So 3, 2, 1, run.
Moo.
Meow.
Proof.
Quack.
Oh, Jeff, we can't hear you.
And then bah. This is perfect. Was everybody, I was like tracing, I was going along. We had a little
Yes.
bug that occurred along the way. So we would need to go into doing some bugs. All
Debugged
right.
it.
Debug it. Okay. All right. So now that was what, guys? That was one thread, right? It was a series of commands, and it was Sunday morning in the barnyard. Now, we don't. I mean, we could probably play like that morning music song, but for creating two threads this time, what we're going to do is we're going to introduce the idea of do, re, and mi. Now, I know it doesn't go with the barnyard, but I'm sure there are some Sound of Music fans out there, which reminds me we should probably do some Sound of Music trivia coming up, Betsy Ann, pretty soon. All right. So for this purpose, all right, Betsy Ann, you're going to stay with the cow. Okay.
Okay.
Nikki, you're going to stay with the cat. All right. Paul, you're going to be the dog. Okay. But Joe, you're going to be do. Jeff, you're going to be Ray. And then I'm going to be me. Do I have that right? Do, Ray, me?
Yes.
Okay. Very good. Now, this time when we do this, we're going to go off at the same time. So Joe, when I get to 1 and say run, you're going to start with do at the same time that Betsy Ann is going to start with moo. Okay.
Oh, okay.
Jeff, you'll go with Ray right after Joe, and then I'll do me. So this is going to be going on at the same time. Everybody got that?
Yes.
Yep.
I missed my instruction.
You're
I'm still going. I'm still second.
You're
You're
still
with-
second.
You're
Perfect.
with
You're gonna go.
Jeff.
You're gonna go right after Betsy Ann. Okay, but
Okay.
there are going to be 2 sets of code. See, this is this communication. This is
Got
this
it.
collaboration, right? This is what we're talking about. Okay. All right. Everybody got it? All right.
Yes.
So 3, 2, 1.
Moo.
Do.
Oh,
Ray.
Meow.
Proof.
Me.
Proof.
All right. Should we try that again, everybody?
Let's try that one more time.
That's
All right.
good.
Okay. All right. 3, 2, 1, run.
Moo.
Do.
Meow.
Ray.
Me.
Proof.
Okay, so we got 2 threads that are going on simultaneously, and we would need to get in that, right? So guys, that's modeling, and I hope that you all are having a laugh at our expense. feel free to throw the laugh into the chat if you would like. But it really kind of gets to that idea. If we were to kind of think about this, how many of you guys were like Muppet fans?
Oh, me, totally.
Or Sesame
Yeah,
Street.
grew up with the Muppets, yeah.
Banana.
Ba-da-da-da.
Look at Jeff's going with it.
Yeah.
So we got that going, right? And then we had like moo ba, right? We would be creating something that was maybe entertaining, right? So this is just sort of like we're creating something. We're creating a computational artifact, which we're going to talk about here in a little bit. So with that, now we're going to transition to Hollywood, and Hollywood's going to take us live with Codejumper. So let me just move back. Nikki, can you go one more slide forward to make sure? I think there might be some concepts here. Okay. All right. So we've got this idea of developing and using abstractions as a core practice. And so, Nikki, that word abstractions, can you talk about what that abstractions word means in this context?
Absolutely. So using abstract elements allows us to perform a specific task. So much like the activity that we just had, we had a bunch of abstract animal noises that we strung together to create some sort of story. Similarly, you could take lines or words from a song that don't have meaning individually, but can be constructed together to form a complete song.
Very good. Thank you, Nikki. All right. So I think that I need to now go to sharing. So I'm going to go in and I am going to share my screen. I'm going to make sure that the sound is good. I am going to minimize this. So on the screen, on the left-hand side of the screen is going to be Codejumper. And on the on the left-hand side of the screen is going to be an image of the Codejumper pods and the hub. And on the right-hand side of the screen is going to be the actual Codejumper app itself. All right. So Joe, you want to describe what it is that we are about to do and what help you need from the crew?
Yes. All right. So what's really nice, this curriculum is really cool because we're taking what we just learned in the unplugged activity, and we're now going to see kind of a more physical computer element to this. So what we're going to do is we're going to set up Codejumper and get multiple threads, and we are going to do, we're going to kind of journal down how we think this thread should play out. So the participants, what we're going to do is we're going to set up, let's go ahead and set up the sound sets first, Jim. So on Codejumper, on thread 1, can we go ahead and set that to Barnyard?
Barnyard? Yes. The Barnyard, or is it Animal?
It's Animal, I believe it is, sorry.
Okay.
I was looking at the unplugged and
Yeah. Okay. So, all right. So, and by the way, if you have a student that's using a screen reader, they don't need to click. This is accessible. Okay.
Yes, you would just tab through and you can choose which what thread you want and then choose the sound set. All right, so just to kind of give people a taste, could you move in case people are new, can you go ahead and move the sound dial just to kind of hear the sounds in the sound set?
Okay. All right. So I'm plugging in a play pod right now. All right. And
can you hear that click to let us know that it's connected?
And we'll have to do a sound check here.
Yep, we got it.
Is that Nikki's cat?
Sounds just like Nikki.
Okay.
Perfect.
All right. There's Paul's dog. Joe, there's your duck. We didn't have a horse, right?
Nope.
I would have loved to have heard Jeff make those noises.
I think I was close.
There's our rooster. And I did not sound anything like that sheep. And of course, every barnyard needs a lion, right? All right. We're back to our cat.
All right. So what you would do, so we're going to have 3 in this sound set. So if we could go ahead and just plug in 2 more play pods to your thread.
All right.
All right, we heard the 3. So what we're going to do is we're going to go ahead and set this up first. So on the first, we're going to have 3 animals. We're going to have a pig. So go ahead and set the first one to the pig.
Oh, there it is.
A horse on the second one. And a duck. All right, so now on thread 2, if we can, let's go ahead and set that, set the sound set to, go ahead and plug a play pod in, and let's move that sound set to people.
Okay.
And just for the interest in time, we won't go through this sound set, but let's go ahead and set this one to surprise.
Oh.
That one right there, that encapsulates a lot, doesn't it?
Surprise!
That's what you
And
want, right? Surprise?
Yep. And then the second one, let's set, go ahead and plug another play pod in, and let's set that to sneeze.
All right, so that was the one that I was worrying about, so hold on.
I think that's a blowing your nose. Yeah, I think that's... There we go.
Oh.
And then
Wait, what did you want? Did you want
sneeze,
a groan or
sneeze? It doesn't matter, but go ahead and do sneeze.
That's the sneeze right there,
There
right?
we go.
Yeah. Okay.
Yeah.
All right.
And then the third one, go ahead and plug that in, and that'll be a groan.
That out here.
Surprise! Oh.
It's not Friday yet.
That's the sound we're all going to make Tuesday when we come back from Memorial Day.
Which was what? Decoration Day.
That's right. So what we're going to do is, if you guys could all journal, so the 5 of you minus me, if we could just journal what order we think we should put these in to make the most sense. So we have 6 sounds. So recapping, on the people side, we have a surprise, sneeze, and a groan. And on the barnyard side, we have a pig, duck, and a horse. So if you guys could just go ahead and journal down, take a second, journal down what order you would like to hear these sounds in. And then, do you want me to go ahead and introduce the pause pod now? Or do you want to?
Yeah, because the
yeah,
team
let's go
is
ahead and
thinking about this. Yeah, okay. So we want to introduce a pause pod to each string, right?
Yep. So we're going back to when we were introducing the kit, we have pause pods. So Sully's going to plug a pause pod into each thread, and this is going to allow us to create sort of a pause in the sounds.
Okay. Do we want the pause, to be the like, for instance, the second for both, or could it be the pause? Could the pause be like the second one and the third in another?
We could do it either way.
All right. We'll have to talk to the team. I guess we'll have to talk to the team.
Yeah, let's see what they want. Yeah.
Right.
So in your journal, yeah, we'll throw that to collaboration. Actually, I like that better. Yeah.
Okay. All right.
All right. Are you guys done journaling?
Yeah.
And who would like?
Yeah.
Okay. Betsy Ann, let's have you go first. What order do you think they should go in?
So for the human sounds, I think it should be like everybody's hiding and someone sneezes. So the sneeze goes first. Everyone else groans because they're upset that they ruined the surprise with the sneeze. And then third, it'll be the surprise sound.
All right.
Oh,
I like that. Nice thinking. And what about on the barnyard side?
And sorry, what are the sounds on the barnyard side? I was putting my effort into humans.
Oh, you're fine.
Pig, horse, and duck.
There you go.
I would choose to go dog, pig, then horse. Like the dog disrupts
sorry, it's
the
a
pig.
The duck.
It's a duck, not a dog.
Oh,
that changes.
well then I have to go
everything,
back to my
doesn't
computer science journal.
it?
I went duck, horse, pig is what I hit. That was.
What did you do, Jeff? What'd you say?
I did duck, horse, pig is how
Duck, duck, horse.
because of course I'm a fan of the pig, so we want the finale.
You want that to be
Oh.
the last. Okay.
Plus,
All
it's
right.
terrifying.
So where would we want the pause in there?
It's
I-
only
I
one
would-
pause, right?
There's one on
pause
each thread.
for each thread.
Hmm.
So maybe the pause like in between the groan and the surprise.
That's exactly what I
Yeah,
was
that's a good
thinking.
place for it.
All right. You guys are taking notes in your journal because you're going to have to tell me what to do. All right. And then since what about the pause for the if we put the pause at the very start of the animal sounds, we probably will hear each one. They won't be happening simultaneously until we get to the end, right? Theoretically. This is that computational thinking that's coming in.
Well, it would slow down the first one, but would it affect the other ones?
Yeah, it really won't affect the other ones, I don't think.
I don't think it
Well-
would. I was thinking put it since Jeff wants the finale of the pig. I would say put it just before the pig.
Just before the pig? Okay. All right. All right. Now we can also make adjustments to remember, we can make adjustments to the rate at which these sounds occur, right? And the beats on the pause pod. So they can be a pause with a couple of beats. But, one of the things that we could do is we could just sort of, once we get the sounds where we want them, we could just run with it and then tweak it, right?
Yeah, that sounds good.
Okay.
Yeah, I think let's go ahead and run through once and just see what it sounds like and then get some input back from everyone.
Okay, so I am going to work with the first thread. And so the first thread are the animal sounds. And so the first animal sound needs to be what?
Duck.
Duck. There's our duck. All right, our second animal sound needs to be what?
Horse.
A horse.
And the third animal sound needs to be pig, right?
Pig, the pig.
By the way, that. All right. And the first people sound needs to be what?
A sneeze.
Sneeze. Yeah.
There we go. The second one needs to be what?
Groan.
Yeah, this is lining up perfectly. The third one needs to be
Surprise.
all right. Okay. All right. All right. So Joe, what were to happen if I were to press both of the buttons on the hub simultaneously?
That's going to read out the code that we have selected. So on the screen, those who are light dependent who can see those, you're going to actually see probably the written out code on there. On the but when you actually hit the 2 play and stop button at the same time, it's actually going to read in a computer voice, kind of the Microsoft David voice, that what the code actually is. So you go ahead and do that. It'll read both threads.
All right. And we'll just kind of go through part of them. So I'm pressing both
Yep.
of these together at the same time.
Thread 1 Animals. Play duck for 1 times speed. Play horse for 1 times speed. Pause for 1 beat. Play pig for 1 times speed.
So I hit the stop button and it stopped reading after that read through that first thread. Otherwise, it would have gone through and read through the second. So it gets into everybody can access this, right? We've got a visual for the light dependent kids in the class. We've got the audio for the kids who maybe need the audio or learn better by listening. So
Now, Sully, we haven't talked about one thing. On the pause pod, you have a dial and you can control how long you want the pause to be. Did we actually determine how long we want that to be?
we did not, but we should probably go back to our class and ask the question.
Yes.
So on the animal thread, Paul, what do you want the pause to be at?
Let's make it, can it go half a beat?
Half
You
a
How
can,
beat.
about that for an answer? All right. And for the people thread, Nikki, what do you want the pause to be?
Let's do 1 beat for that one.
A quarter beat. Half a beat.
All right.
1 beat.
All right. Are you guys ready to run our computer program?
Yes.
Yeah.
All right, here we go.
Oh.
Look at that, Jeff.
The pig steals the spotlight.
Excellent.
Now,
Excellent.
Betsy Ann, how do you feel about the pigs stealing the spotlight?
I not a huge fan, Jeff. I would love to end on surprise, but I know Jeff is a huge fan of the squealing pigs. So we maybe be able to find a compromise.
Yeah,
I'm willing to compromise a little bit on that. Yeah.
you are. All
Yeah.
right.
Yeah.
All right. So here it kind of gets into each one of these pods being able to be controlled with regard to the rate at which the sound is being played. Each sound is a little bit different in terms of its length, but we can speed up and slow down the sounds. And so it sounds like we either want to slow down all of the people noises or we want to speed up the animal noises. Does that make sense?
Yes.
All right. So if we just walk through this, because I'm sure the audience is probably like ready for us to move on. I think my computer is going to die here pretty soon too. But if we just sort of went through those threads and we were to say we wanted to slow down the people sounds, this could get pretty painful. But let's go to the sneeze. So that's fast.
Sounds like the lion.
And that's really slow. Yep. All right. So now we're going to move on to the groan. So that's fast. That's really fast.
Oh,
Sounds like my
no.
stomach. So we want half a beat.
A
We want
quarter beat.
And then
Surprise!
Surprise!
Oh no.
oh no is right. All right. All right. Are we ready to run the program?
Almost as scary as the pig.
Yeah.
All right.
Yes.
All right. Here we go. Man, that was pretty good.
I really liked that.
Made kind of a nightmare. I love it.
Yeah. Yeah.
Mhm.
Right. So I'm going to have to find my charger here pretty quickly, or I may be exiting, which everybody might be really excited about. But yeah, so lots of communication that's going on there. I'm going to go ahead and stop sharing my screen, and I guess we could sort of throw out to the audience any questions or any comments. Nikki, if you want to go ahead and start sharing the screen again. Okay. And if you could move to the, actually, this would probably be a good recap. So just stay right here. So audience, do we have any questions at this moment in time?
Nothing in the chat.
Okay. All right. All right. So this guided activity used multiple threads to create a computer program, and it included the hub, which was the heart, right? Bluetooth. You can connect up to four different threads. So we could have had 4 different sound sets that were going on at that time. A play pod, which allowed us to be able to control what sound and then the rate at which the sound was played. A pause pod, which interrupted the commands themselves and allowed us to be able to adjust by beats. And then you saw us talking about the computer science journal. And that journal, right, you heard me say, write it down, right, Paul? So if we were asking you to write it down, what kind of tool would you be using to write down in your computer science journal?
Could use a note taker if I had one. Could use just a regular keyboard for the computer, could even use a braille writer, could even use a Mantis.
Yeah, and I was one of those individuals, and still am, who has really poor handwriting. And so my computer science journal could be something that I could, speak, right? Audio style. So, all right, let's move on to the next slide. So two more core practices, and that is creating computational artifacts and testing and refining computational artifacts. So I think when, again, considering curriculum, these are two things to take into consideration. And I think you saw us create that computational artifact, two different sound sets going on. And then you saw us testing and refining the computational artifacts and doing some problem solving in order to be able to do that. And really getting into some kind of computational thinking step by step and how we could go about making some adjustments. Let's move on to the next slide. All right, so Paul, we've got a poll question specifically for the group, so we'll make sure that everybody's with us. I'm hoping that we're going to have 70% participation rate in this poll question. So here we go.
All right, so we've been talking about a lot of these different parts of the framework. So here's a hypothetical. So a group of 5 students from 2 different schools discussing ways to debug a computer program. That's an example of which of the following computer science framework core practices. Is it fostering an inclusive computer culture, communicating about computing, collaborating around computing, or is it all of the above? So you've got a group of students from 2 different schools talking about how to debug a program. And that's going along with which of the following computer science framework core practices: fostering an inclusive computer culture, communicating about computing, collaborating around computing, or is it all of them?
All right. So we're hoping for 70% participation rate in the poll. We've got 22%. The quicker we get this done, the quicker we're over, that we move on and we get to give the credit or the closing code, right, Betsy Ann?
We certainly can.
I mean, I remember sitting in class. I went to Catholic school, and it was like until everybody started singing, could we go out for recess? And it was just painful. And then all of a sudden you had like all of like these 5th graders singing Ave Maria, and it was just it's not working. Although we got to 45%. So, all right. So the answer to this question is obviously all of the above. That collaborating, communicating, and fostering are all going to be going on that situation. And that idea of 2 different schools, kids coming from different cultures, perhaps maybe it's different sides of town, or maybe different parts of the community coming together and discussing, debugging. All of those things are going to be happening. So I think we're about ready to bring this train into the station, aren't we?
We are.
All right. What's our next slide, Nikki? All right, so a summary of our core practices, right? So this is one of our learning objectives, that you would walk away with an understanding that when considering curriculum, you want that curriculum to foster an inclusive computing culture. Everybody can participate. That there's collaboration that's going on around computing, and so if everybody's participating, everybody's going to be able to collaborate. That the curriculum is there to recognize and define computational problems. So it's something that can be thought through step by step. That the students will be developing and using abstractions, and that is theories or ideas. If we do this, then this could happen. If we change this, then this could happen. And ultimately, what we want is that piece going on. Then the curriculum is going to allow the kids to be able to create computational artifacts. And in this case, with Codejumper, it's stories, it's songs, it's poems, it's whatever you want to bring in the form of custom sounds. That they have the opportunity to be able to test and refine the computational artifacts, And then finally, that they're going to have the opportunity to be able to communicate about computing, whether it's in group discussion, whether it's in journaling, and that I think oftentimes we see these kids that are sitting on a computer or on a tablet using Scratch, dragging and dropping things around. And unless they've got, that rock star teacher, and we know there are tons of rock star teachers out there that are really into it, they could be there, doing things independently and not collaborating. All right. And so, Paul, I think it's time to ask, what have we discovered today?
All right. A couple of things. We have figured out that the K through 12 computer science framework provides lots of different guidelines for developing computer science curriculum. And we've also discovered that Codejumper helps schools and districts align with the computer science framework. And I don't know, you may or may not have noticed, but Sully had his own discovery today. We stopped and started recording. Okay. Anyway, the Codejumper kit, if you have not been, please go visit codejumper.com. You can see more about not just this lesson, but all the 19 lessons. And you can also get an idea of some of what's in each one of those lessons. Codejumper is a product on quota, available for $999, not on quota, $795 on quota. All your questions will be answered there. And of course, internationally, Humanware handles the distribution of that, as we talked about earlier. So if you're not in the United States and you want more information, we can get you set up with Humanware to get more information about Codejumper as well.